All right, so this is the second part to lesson 3.1. In the first part, we went over rational exponents and radical form. Now we're going to go over negative exponents. So it's important to understand what an exponent actually means. So as you can see, I have two little examples here. I have 5 to the second and 5 to the third. So an exponent tells us how many times we're multiplying the base, which is 5, by itself. So 5 to the second is 5 times 5. You multiply it by itself twice, and you get 25. 5 to the third, you multiply 5 times 5 times 5, so 3 times, and you end up with 125. So negative exponents are a little bit different, but really all they are is the opposite. And when you think about the opposite of multiplying, you see dividing. So what happens is it explains how many times the number 1 gets divided by 5. So 1 gets divided by 5 2 times. Now this looks a little bit weird, so we can also write it as 1 divided by 5 times 5. And this happens when you distribute the division sign, it changes into multiplication. Okay, so when we look at it this way, 1 divided by 5 times 5, that's really 1 divided by 25, which again looks a little bit better as a fraction, 1 over 25. Okay, so now if I'm looking at 5 to the negative third, I'm immediately going to change it into a fraction. I know it's 1 divided by 5 times 5 times 5, which is 1 over 125. Okay, so that brings us into our rule for negative exponents. When an exponent is a negative, you technically flip it over the fraction line and it becomes positive. So let's look at another example. Let's say I had x to the negative 8 power and y to the 4th. Okay, now this is not a fraction, but if I had to change it into a fraction, I would put it over the number 1, and anything that has a negative exponent is going to get moved to the other side of the fraction, which in this case is the denominator. Y to the 4th is perfectly fine. That's a positive exponent, so that stays in the numerator. And x to the 8th would get moved to the denominator and become positive. Okay, so it's like a magic flip over your fraction line, and that makes the exponent positive. Now, it can go the other way. If I wanted to see all negative exponents, you would flip it over the line, which would be x to the negative 8th over y to the negative 4th. Okay, but typically we always want to make the exponents positive, and we just did that. Okay, so we're going to try a few examples, and we're going to look at a few Regents problems, and that'll be it for this lesson. All right, so we have 5 examples here that we're going to go through. Our goal for every example is to have no negative exponents, so to get rid of all of the negative exponents. Your first step is going to be to simplify. We always want to simplify first, and then if anything, we'll work with the negative exponents once we simplify. So 24 over 12 simplifies to 2 over 1. And when you're combining like terms, like we are with x to the 6th over x to the 8th, if I just had x to the 6th over x to the negative 8th, remember, you're doing 6 minus negative 8, which is actually a positive 14. If I was just doing that, it would be x to the 14th, right? Just x to the 14th, and technically x to the 14th is over 1. So when you're combining, that's why your answer goes in the numerator, because it's really over 1. So x to the 14th. And luckily, this one's done. We didn't have to do anything else. The exponent turned out to be a positive number when we simplified. And our final answer would just be 2x to the 14th because we don't have to put it over the number 1. For the next one, we're going to do the same thing. Try to simplify. So 3 over 12 reduces to 1 over 4. I'm going to work with my x's. So I have x to the 2nd over x to the 6th. 2 minus 6 is negative 4. and that goes in the numerator for now. And then I have y to the negative third minus y to the third. Well, divided by y to the third, but we're subtracting the exponents. So 3 minus 3, negative 3 minus 3 is actually negative 6. So y to the negative sixth. All right, and now you just got to fix your problem and make it have all positive exponents. So like we saw before, when it has a negative exponent, you move it to the other side. In this case, the other side is the denominator. So the 1 stays in the numerator. In the denominator would be 4, and x to the 4th, and y to the 6th. That's it. That's your final answer. Okay, once you get all positive exponents, you're done with the question. Next one. A little different because this is the power rule. We have one term that's being raised to a power. Okay, we could technically distribute if we wanted to, or we could distribute later. Either way, you should get the same answer. For now, I'm going to distribute. Everything has to get raised to the negative second. So we would do 2 to the negative second, x when I multiply. So I have to multiply 3 times negative 2, which is negative 6. And then y to the negative third to the negative second would be y to the positive sixth power. And now we just have to fix it. So the ones that have negative exponents are 2 to the negative second, that's going to have to get moved to the bottom, and x to the negative sixth, that's going to have to move to the bottom. So it would be y to the positive 6 would stay in the numerator, over 2 to the positive second, and x to the positive 6th. If you have a numerical base like you do here, you actually want to simplify it and figure out what it is. So it would be y to the 6th over 2 squared is 4, x to the 6th. That's your final answer. Okay, so make sure if anything ever has a numerical base that you actually solve and you figure out what it is raised to that exponent. All right, so for the fourth question, we have 2x to the 4th and y to the 6th raised to the negative 1/2 power. There's two different ways you could do this, but we're actually going to make the exponent positive first by putting this over 1, and then flipping this entire term to the bottom because it has a negative exponent. So there would be a 1 left in the numerator, and the denominator would be 2x to the 4th, y to the 6th, and then to the positive 1/2. And then you would distribute the exponent. So the other way would have been to distribute the exponent first and then make everything positive. Either way, you get the same answer in the end. So once I distribute the exponent, it becomes 1 over 2 to the 1/2. And then we multiply when we're raising a power to a power. So it would be x to the second, because 4 times 1/2 is 2. And then 6 times 1/2 is 3, so y to the third. And then the only thing you could fix is this radical, or you can fix this into a radical. 2 to the 1/2 is really the square root of 2. So it would be 1 over radical 2, and then x to the second, y to the third. And I'm going to bring another concept into this because if we wanted to rationalize the denominator, we would multiply the numerator and denominator by rad 2. And then your final answer for this would end up being radical 2 over, remember a radical times itself is just the number underneath, so 2x to the second and y to the third. That would be your final answer. All right, and we're actually going to skip the last question. It didn't work out very nicely, so we're going to move on to the Regents questions. All right, so this one says the expression m squared over m to the 1/3 raised to the negative 1/2 power is equivalent to. So you always want to try to simplify first. I can simplify what's inside because they have the same base, and when I'm dividing two terms with the same base, I subtract the exponents. So we're going to rewrite it, m to the second over m to the 1/3. I would be subtracting 1/3 from 2. So 2 minus 1/3, that's raised to the negative 1/2. 2 minus 1 over 3 is 5 over 6. So you would get m to the 5 over 6 raised to the 1/2, negative 1/2 power. When an exponent is raised to another exponent, you multiply. So 5 over 6 times negative 1/2 turns into m to the negative 5 over 6. So you can notice how that's not one of your answers because you have to change it to a positive. To change it to a positive, it's really over 1, and this whole thing would have to get flipped to the bottom. So now what you have to remember is that this m really has a coefficient of 1, which is going to stay in the numerator. So this would become 1 over m to the positive 5 over 6. And this is bringing us back to part 1 of lesson 3.1. That answer is not one of your choices because they put their answers in radical form. So we're going to have to change that into radical form. But I kind of already can see that I can get rid of choice 1 and choice 3 because they are not a fraction. They don't have 1 in the numerator, and they're really just over 1, each of these. So you would cross off choice 1 and 3. Now, if I want to change 5 over 6 to a radical, it would become 1 over, and it's power over root. So it would be the 6th root of m to the 5th power. And that would be choice 2. Okay, so this question combined changing rational exponents into radical form and also working with negative exponents. All right, so this question is also, again, combining your rational exponents and negative exponents. So this question is asking us to justify why this big radical expression is equal to this expression. So we're going to have to work with the radical expression and change it into rational exponents. So we know that from property of multiplying radicals that if I have two radicals, I can turn them into 1 or vice versa. So us having x to the 2nd and y to the 5th under the same radical means that I can break it up into the cube root of x to the 2nd times the cube root of y to the 5th. And it's the same thing for the denominator. I have the 4th root of x to the 3rd times y to the 4th. So I can break that up into the 4th root of x to the 3rd times the 4th root of y to the 4th. So now what I'm going to do is I'm going to change both of those radicals, or all 4 radicals, to be rational exponents. So each of them are going to be power, which are all the exponents, over root, which are all the root indexes that are attached to the radical in the front. So my first one would be x to the 2 over 3 times y to the 5 over 3. In the denominator would be x to the 3 over 4 and y to the 4 over 4. Okay, so now I'm looking at xy in the numerator and xy in the denominator, and I know that I can simplify those. So I would put them in my calculator, but if we're doing it the long way, you want to get both of these denominators to be the same. The least common denominator would be 12, so I would multiply this fraction by 4 and this fraction by 3. That would make them 12 in the denominator. Same thing for this fraction. Technically, 4 over 4 is just 1, so you can also look at it as 1 over 1 and multiply this fraction by 3 to get it to be the same denominator that matches the y term in the numerator. 2 times 4 is 8. 4 times 3 is 12. So it's x to the 8 over 12 over 3 times 3 is 9. 4 times 3 is 12 minus 9 over 12, or x to the 9 over 12. Then you have your y is 5 over 3. We didn't have to do anything to that one. And the y in the denominator would be 3 over 3. Okay, so notice how all of the denominators match. The denominators for the fraction of the exponent of the y term match, and so does the denominator of the fraction in the exponent of the x term. So then you combine like terms. We subtract the exponents. 8 minus 9 is negative 1 over 12, and 5 minus 3 is 2 over 3. Okay, which we just proved to be the same thing as what they mentioned in the question. Okay, so you had to break it down into separate radicals, change each of those radicals into rational exponents, and then either you could have just used your calculator for this part. So you could have done x to the 2 over 3 minus 3 over 4. You could have put what I'm boxing off directly in your calculator. We just did it the long way to practice LCM. And then y to the 5 over 3 minus, and you could have put 4 over 4. 4 divided by 4 is just 1. So you would have put this in your calculator, and it would have given you negative 1 over 12 and 2 over 3. Okay, so justifying means that you just have to use either your work or your explanation, but justifying your work counts. And that's how you do this problem. So I hope this helped. Study hard and good luck.